Let's see an example of using functions in a business application. This type of application, by the way, is called straight-line depreciation. The value of a copier during its first 3 years of use is given by V of t equals minus 2,100t plus 15,000, where t is the time in years since its purchase and v is the value at that time in dollars. Let's find v of 1 and v of 1.5 and we'll interpret what these mean. And then after that we'll find the domain and range of the function. V of 1 is going to be what we get if we plug in that number for t. And that number is 1. So we have minus 2,100 plus 15,000, which is 12,900. So what does this mean? It means that the value of the copier 1 year after purchase is $12,900. What's v of 1.5? Again, to evaluate a function, we're going to plug that number in for the variable. I think I explained this before. One way of doing this, if you have trouble evaluating functions, is to put a parentheses, empty parentheses, where the variable was in the formula, and then you just put the number in wherever you have empty parentheses. That gives us minus 3,150 plus 15,000, which gives us 11,850. And what that means is the value of the copier 1 year and 6 months, or if you want to just say 1.5 years, that's fine too. Anyway, that's after purchase. Is now down to $11,850. Let's move on to the domain. Now here's a common error in this type of problem, and that is to look at the function and say its domain is all real numbers because there's no problem numbers I have to throw out. There's no dividing by the variable. There's no square rooting of the variable. So a common error is to say domain is all real numbers, which in interval notation would look like minus infinity to infinity. And that's a very understandable mistake to make, because if I just gave you this function and asked you what the domain of this function is, the correct answer would be all real numbers. But this function isn't standing alone. It's part of an applied situation. So we have to look at the words that describe that situation. And if we say all real numbers, what we're missing out on is that the setup here says the value of the copier during its first 3 years of use. This function does not apply after 3 years go on. It only applies to this copier for 3 years. And so that means that the correct answer is that the domain is t-values starting at 0 and going up to 3, which in interval notation would look like square bracket 0, comma 3, square bracket. Now, what about the range? Remember, I said that for the range, we have to look at the graph. So let's think about what the graph would look like. Fortunately, this is a linear function. So we can pretty easily produce at least a rough graph. We're not asked to give the graph, so you can almost think of doing this off on scratch paper just to figure it out yourself. So we don't need to do a perfect graph here. So I'm just going to notice that this is, of course, in mx plus b form, or we might want to call it mt plus b form since our variable is t. So anyway, I see that the y-intercept is $15,000. So it would start here. And then it's got a negative slope. Negative slope means it's going downhill. I'd be a little more precise about the slope if I was producing the graph, but I'm just trying to get an idea of what's going on here. So I'm just going to draw a line through that y-intercept going downhill. And then let's remember, though, that we don't actually want this whole line. Let me do this. We don't actually want the whole line because our domain is only the stuff between 0 and 3. So we wouldn't really even need to draw that dotted part. I'm just emphasizing that if you're thinking of the function, it's the whole line, but we have to think about the domain as well, which is 0 to 3. So I can see that it's going to go, the y values are going to go between whatever that lower dot y value is and then up to 15,000. So all we need to do to determine the domain is figure out what goes in for this question mark. And, well, that would be whatever v of 3 is. Whatever the value after 3 years is. V of 3 is negative 2,100 times 3 plus 15,000. So that's negative 6,300 plus 15,000. And that gives us 8,700. So our range is v values ranging from 8,700 to 15,000, which in interval notation would be square bracket 8,700 up to 15,000.